and thanks for clicking on this next Narculus production. Today, we're going to be talking about part 2 of algebraic limits. We're going to be using more of those techniques that you can use to get yourself out of an indeterminate form. Okay, we'll see how those work, and we'll also calculate a couple of limits that are going to be important, or one limit that's going to be important at the end. Okay, so let's get started. Remember, 0 over 0 is our one indeterminate form right now. We talked about on the last video why that's the case. How do we get out of an indeterminate form? We need to figure out WWA A1KD. What would an Algebra 1 kid do? So remember, Algebra 1 kids can do things like factor, they can FOIL, they can multiply out things, they can multiply by the conjugate, they can combine fractions. There's a lot of things Algebra 1 kids know how to do. And that's what we're going to work with here, some of those different techniques. All right, so let's start by finding the limit as x approaches 2 of that mess that you see there. So let's take the limit of the numerator first and see what we get. We are going to get, looks like 6 minus 2 squared minus 2 plus 2 squared, which is 0. And then underneath, limit as x goes to 2 of x minus 2, also 0. 0 over 0 is indeterminate. So let's take a look. What would an Algebra 1 kid do with what they see up top? Well, they see this and that. They know how to multiply that out. So that's what you should do. Multiply it out. So let's rewrite it first. And we're going to multiply out. Here we go. So we got 9x squared minus 6x, another 6x, plus 4 minus, now I'm going to put the second half in parentheses because I'm going to have to subtract everything that I see on the right-hand side. So it's x squared plus 2x plus another 2x plus 4. Distribute the negative, still over x minus 2. And let's see what we got. We got a limit as x goes to 2 of 9x squared minus 12x plus 4 minus x squared minus 4x minus 4 all over x minus 2. Okay, now I got to put together some like terms here. So 9x squared, they go together. Those two go together, and the 4's drop out. So that gives me the limit as x goes to 2 of 8x squared minus 16x over x minus 2. Okay, now, we multiplied the whole thing out, but remember, the goal is to eliminate the 0 over 0 indeterminate form. Why do we have an indeterminate form? Because there's an x minus 2 under here, and when I'm putting 2 in, 2 minus 2 is giving me 0. So there must be an x minus 2 up top to eliminate that indeterminate form. So I still haven't eliminated the indeterminate form, even though I multiplied it out. But I can factor in the numerator. Take out 8x, it's a GCF. There's my x minus 2 that I'm looking for. So that cancels out the x minus 2 underneath. It gives me the limit as x goes to 2 of 8x, and 8 times 2, that's 16. So this limit is 16. Okay? All right. So remember, never lose sight of what is giving you that indeterminate form and what has to get removed somehow. Okay? And remember also, x equals 2 is a removable discontinuity. There's a hole at the point 2, 16, which again, we'll use going forward. Okay, so there's a typo in this one here. We want to make that a 4, not a 3. All right, so now let's try it. You'll see what happens. The limit as x goes to 3 of the square root of x squared plus 7 minus 4 gives me the square root of 9 plus 7 minus 4, which is the square root of 16 minus 4. That's 0. On the bottom, sure enough, of course, you get 0. That's 0 over 0 and indeterminate. So we're going to try to algebraically manipulate this. Now, what you notice is An Algebra 1 kid probably wouldn't be quite sure what to do with this, right? They're used to removing radicals from the denominator. We do that all the time, okay? But there's a radical here in the numerator. I can't take the square root of each one of these, all right? That you should know. You cannot take the square root of each one under addition, okay? So the question is, how am I going to deal with this issue? Well, what I'm actually going to do, and we do this a lot in calculus, is we're actually going to multiply by the conjugate in the numerator. So we're going to multiply by the conjugate of the numerator. That's the square root of x squared plus 7 plus 4. We're going to multiply that on the top and on the bottom, numerator and denominator. Okay, that still leaves me with the limit as x goes to 3. I'm going to start multiplying. Square root of x squared plus 7 times the square root of x squared plus 7 is x squared plus 7. And then the two middle terms are going to cancel out in a minute. I'll write them here so that you can see it, but they will cancel out. And then I have a negative 16 over there. And then on the bottom, I now have an x minus 3 times the x squared plus 7 in the square root plus 4. Notice I'm not multiplying out the x minus 3 times. I'm not going to FOIL this, okay? And hopefully in your head you're saying, oh, yes, I wouldn't want to FOIL that, right? Because remember, what is the goal? We have 0 over 0. We need this x minus 3 to go away. It's giving me 0 in the denominator. If I FOIL this or multiply it out, well, then I'm going to have to get the x minus 3 back again. I'm going to have to somehow take out the x minus 3 again to get it here so that I can cancel it. So don't multiply that through on the bottom. We're just trying to manipulate the top right now. We're trying to find an x minus 3 somewhere. So these cancel out in the middle. It gives me x squared plus 7 minus 16 is negative 9. And then I have x minus 3 times the square root of x squared plus 7 plus 4. All right, so now here we go. X squared minus 9, that factors. X minus 3 times x plus 3. That's good. That's really good because that'll cancel out the x minus 3 that's underneath. So now I just eliminated my 0 over 0. So now I'm going to evaluate. The limit as x goes to 3 of x plus 3 will be 6. And then underneath, the limit as x goes to 3 of the square root of x squared plus 7 plus 4 is the square root of 9 plus 7 plus 4, which is the square root of 16 plus 4, which is 8. So the limit then is equal to 6 over 8, which reduces by 2 to 3/4. This limit is 3/4. Okay, and there's my correct answer. All right, so in this class, we actually conjugate the numerator more than we do conjugate the denominator. Okay, and finally, one more. You're going to see a lot of this. Okay, here's a function, f of x equals x squared. I want you to find for me the limit as h approaches 0 of f of x plus h minus f of x all over h. This is very important. Okay, by very important, I mean there's 3 operations in this course. This definition is the definition of one of those operations. Okay, so that's how important it is. We're going to see this a lot coming up. But for now, I just want you to calculate this limit. So let's see how we would go about doing that. You're going to have to find a couple of things for me. Well, one thing really. You're going to have to find for me f of x plus h. So I know f of x is equal to x squared, and I want to find f of x plus h. So that means to me that I'm going to replace all the x's with x plus h's. Okay? Just like if I were to say to you, we'll do this as an aside here. It's not relevant to, it's not part of this problem. But let's say I were to ask you to find f of 3. F of 3 means replace x with 3. So you write 3 squared, the answer would be 9. Okay, so instead of now writing x, you'd write 3 there. So then you replace all the x's with 3's, replace the x with a 3, you get 3 squared. Here I want you to replace the x with x plus h. So in place of x, you're literally going to write x plus h and then square it. Okay, so the limit as h goes to 0 of f of x plus h minus f of x over h is the limit as h approaches 0 of x plus h squared. That's what f of x plus h is. Okay, this is the f of x plus h part. Minus f of x. What's f of x? Well, it's x squared. Minus x squared all over h. Okay, now you can see what happens. We could do it here if you want. If I find the limit as h goes to 0, yep, of the numerator, x plus h squared minus x squared, I get x plus 0 squared minus x squared. But that's x squared minus, that's 0. And in the denominator, the limit as h goes to 0 of h is 0. This is 0 over 0. It's indeterminate. So now, what would an Algebra 1 kid do with this? Well, an Algebra 1 kid, they'd multiply this out, right? X plus h times x plus h. We can do that. All right, so let's do it. X plus h times x plus h minus x squared over h. Okay, here we go. So we're going to multiply. We got x squared plus 2xh, right? All right, hold on. Let's take one step at a time here so we can see it. Plus xh. Whoops. Try one more time. That one times that one. xh plus h times x is hx or xh. Doesn't matter what order I write it. Plus h squared minus x squared all over h. Remember, think about your goal. You have 0 over 0. I need this h to go away somehow. So x squared minus x squared zeroes out. That gives me, the limit as h goes to 0 of 2xh plus h squared all over h. And now, there's a GCF up top. GCF is h. That's good. The h's cancel out. It gives me the limit as h goes to 0 of 2x plus h. But h goes to 0, so that's 2x plus 0. That's 2x. I get a variable expression for my answer. The answer for this limit is 2x. Again, you're going to see the importance of this coming up. But yes, your answers can also be expressions as opposed to just numbers. And this has meaning. Okay? And we're going to talk about it, like I said, in a future video. All right? And as always, that's it. Thanks for clicking.